Good evening, everybody, and welcome to being to the second Share It event from ThoughtWorks Italy. So I am Vanessa Formicola, and just a second, technical difficulties here. Okay, sorry. So I'm back. So I'm Vanessa Formicola. I'm a developer at ThoughtWorks. I currently work for ThoughtWorks Italy. I used to work for ThoughtWorks UK. That's a thing that we do a lot at ThoughtWorks. And my pronouns are she and her. We truly care in the Share It community to make sure that everybody from any gender feels comfortable in this community. So let's move on. So for who's not familiar, ThoughtWorks is a global consultancy. We have many offices, as you can see, all over the world. And especially, we have a very diverse workforce with people that come from all over the world and any background. So you might know us, you might have come across some of my colleagues by the books that we publish, or the Tech Radar, which is usually quite well known, or blog posts, like for example, Martin Fowler's blog, or one of the books that you can see there. So one thing that is really important for us at ThoughtWorks is to share knowledge and also to learn. So we have a strong learning culture. And this is part of what we're trying to do with Share It. So what is Share It? So this is an Italian technology community that hopes to empower individuals and organizations by sharing knowledge with others. And we would like to also, learn from everybody else. Like, we really look forward to the conversations that we will have in the chat, for example. And how do we plan to do it? So we plan to do it by having a series of events. We try and organize once every month, more or less. And the topics will vary a lot. So we will go from architecture to potentially pure technical topics, to product topics, to design, and even diversity and inclusion topics, all things that truly represent the culture of ThoughtWorks. We try and represent and share it. And we also have quite a diverse set of speakers too from all over Europe at the moment. So we ask you though, I know this is a little bit of the boring part, to follow a code of conduct. We truly care about making sure that the experience people have in this community is one that makes them comfortable. So we say that there's no such thing as a silly question. So any question is valid. Please share them with us in the chat, and we will try our best to bring them to the speaker so he can tell us, he can give you some answers. We ask you to be kind and respectful in your interaction with the other attendees and the speakers and everybody else. And we ask you to open your mind towards a position of learning. And that's the same that we will do every time we walk a room, hoping to learn something new from somebody else. And without further ado, I'll introduce Matteo Di Tucci. Matteo Di Tucci is a colleague and fellow developer at ThoughtWorks. He's currently writing a book, and he used to work also in ThoughtWorks Spain, and now he's a colleague in ThoughtWorks Italy, and he's going to tell you more about onion architecture. So I will stop sharing so that Matteo can share.
Hello, everybody. Hang with me one sec. And I hope at this point you see my screen. There should be an onion and then a title with onion architecture. Vanessa, I wait for a feedback from your side that everything works, and then I'll start.
Please go ahead.
All right, cool. So again, welcome everybody. My name is Matteo, and as you might have guessed, we're going to talk about onion architecture. And before we jump on directly on the talk, let me do a little bit of introduction. So the first bit is that I want to briefly introduce myself, even if Vanessa made an excellent job in summarizing who I am. So yeah, long story short, I'm a developer at ThoughtWorks. I swear I smile much more in pictures aside from this one, and I hope you're gonna see this also in the rest of the talk. And I'm also very passionate about software design, so much that I'm writing this book that you can find here at this URL. The book is 100% free, so I don't make any money out of it, and I'm not planning to do any commercial use of the book also in the future. And I hope to make this book collaborative. So you can go at this URL, and if you don't agree with, I don't know, maybe I got wrong the solid principle or anything about design that I wrote about, you can open a pull request and say, hey, Matteo, I think you didn't really understand, I don't know, the do not repeat yourself principle, or I think this code example is a little bit convoluted. So I would really appreciate to receive feedback on this. Again, feel free to open a pull request or just send me a message on this LinkedIn handle. Plus, you don't need to take any notes, not just for this slide, but in general for the talk, because we're going to hand out the whole deck at the end of the presentation. And the next thing I would like to do is start with a bunch of thank you. So public speaking gives me a little bit, actually, yeah, it gives me proper anxiety. At the end of it, I enjoyed it, don't get me wrong. But before it, like why I did this. So these are the names of a bunch of people who were super patient. And during the last week, they were attending a dry run of mine. And they also made the extra effort of coming back to me and expressing feedback. Plus, an extra thank you to Alberto, who is an ex-colleague of mine in ThoughtWorks Spain, and actually he's the first person that introduced me to this onion architecture pattern, and I liked it so much that I made a little talk out of it. All right, so the thing is, I would like to make a promise to you all, and in particular, I promise that at the end of this talk, you will be able to answer these 3 questions. The first one is, what is an onion architecture? The second one is, why should I use it? And finally, how to implement it. And the talk itself is structured this way. So there's going to be 3 big sections, and I will stop at the end of each of these sections. First of all, because I will need to take a little bit of breath and also a sip of water, but also so that Mario, Ronnie, and Vanessa can collect questions, because unfortunately, I don't see anybody, and also I cannot see the chat in YouTube. So please don't be shy about asking questions. And also, you don't need just to ask questions. You can just say, hey, I don't know, I think you got this concept wrong, or I implemented this bit in a project, same context as yours, but in my case, it was super difficult and very painful. So again, as Vanessa said, this is the talk, so I'm going to do most of the talking, but let's make this as much as a conversation as possible. So you don't need actually even to ask me a question or make observation on what I'm saying, but even talk to each other and tell your different experiences in the YouTube chat. All right, so if this is clear, we can start with the first leg of the talk. So we're going to answer to the question, what is an onion architecture? So spoiler, onion architecture is yet another architectural pattern. So it's not something magic or specifically fancy. And as every pattern, I had better to start with the problem. So there is a problem that the onion architecture solves. And instead of jumping directly to the definition and the benefits and the cons, I will start describing the problem to you all so we can get on the same page and try to understand really why onion architecture is so important in some contexts. So let me set the stage. Let's assume that we'll work on a project. And if we open IntelliJ, the code base looks like this. So there is one single package, or if you're not used to Java, we can say this is a one big folder. And inside there are all these classes. So if you take some time to read a bunch of names, you see there are services, there are stuff that looks like domain, I don't know, cart, item, shopper, but there are also classes that smell like data, because they have the repository suffix, like cart repository or inventory repository. So the problem with this one huge folder is that there is no separation of concerns. So everything is here. There is UI, there is data, there is domain, there are services. And so everything is in the same bucket, in the same folder. So you might say, all right, I get it, but what's the deal? So why should I care that everything is in the same bucket and there is no separation of concerns? And the first problem is that without separation of concerns is very difficult to reason about code. So even just imaging or discussing about code gets difficult because everything is there. So when you need to do some changes, it's very difficult to express yourself and try to mentally visualize code. In this case, the example was kind of dummy. I don't know, I think there were less than 10 classes, but imaging dozens, if not hundreds of classes in just one folder. And the second thing is that it's very difficult to enforce encapsulation. The typical problem is that, I don't know, another developer or the architect of the project says, let's never call the database from the user interface. And the reason being, for instance, that all the authentication and authorization is done in the application layer. And if we want to enforce this constraint, it's super difficult because even if we do this with manual code review, or better if we do use static code analyzers, it gets super tricky because we should base our checks on the name of classes or their content, and it gets super messy and it gets super difficult. So again, if this is the problem, the solution historically has been a pattern called layered architecture. So the layered architecture tells us two things. The first thing is that we should split concerns in different folders. So one folder, one concern. And usually if you Google layered architecture on Google, you're going to see that usually the 4 layers, and when I use the word layer, is a synonym of folder. So I'm going to use them interchangeably, but I'm meaning the same thing. So again, layered architecture, you Google it, and you see that usually there are 4 tiers, 4 layers, 4 folders. And usually they are application, domain, persistence, and presentation. Of course, if you're working on a backend project, you're not going to have the presentation layer, so it's going to be just 3. And so again, first leg in the layered architecture pattern, you should have different concerns in different folders, usually these 4. And the second thing that this pattern prescribes is that you should have a very strict dependency direction between this folder. So presentation should only know about application, application about domain, and domain about persistence. And the key point here is that the persistent layer, or if you want, again, the persistent folder is the center of the universe. Everything revolves around this. And this happened for mainly 2 reasons. The first one is that historically, there used to be a lot of emphasis on database. So I personally work on projects where the first thing that we did was defining the database schema, and then we start writing the code on top of it. But the main thing that, the main reason why the persistent layer in this pattern is the center of the universe is that if you think about it, it's kind of natural that the domain depends on the persistence layer. Let me give you an example. Let's assume we are, I don't know, in an e-commerce website. So the user works on the UI, then clicks a button, and a bunch of data move to the application. There is, I don't know, validation, authentication, et cetera, and then at some point we touch the domain layer. So I don't know, maybe we can apply some discount because we just added a bunch of items in a cart. But at the end of it, we need to do something with this data. So we need to persist this, or let's say produce an output out of our application. And historically, this meant to write something in a database. This is also true for the retrieval of information. And you see that there is a strong connection between domain and persistence, and domain is kind of in an inescapable way depending on persistence. And at this point, you might say, cool, you started this talk telling us that you're going to introduce a problem, you did, but then you're solving this with the layered architecture. So what is the problem here? And the thing is that layered architecture is cool, but it introduces a main pitfall, which is that the domain depends on persistence. And this is the main problem that the onion architecture wants to solve. And actually, I think it pretty much solves it. So again, domain depends on persistence, but what's the deal? So why it's so bad that the domain depends on the persistent layer? And the thing is that first is anything you change in the persistent layer will force you to make changes also in the domain. So if you switch from, I don't know, Oracle to MySQL, then this does not affect just the persistent layer, but also it will have ripple effects on the domain layer. Or let's say, I don't know, we are moving out of a database and our persistent layer is actually dropping a message in a queue or calling a resting point. If we do this, we need to modify also the domain layer. And this is kind of smell like it's not that cool, because at the end of the day, domain shouldn't be bothered too much about the infrastructure, like how we, I don't know, for instance, deploy or which is the technology that we pick about the persistence. Because again, domain should be just bothered about the domain concern. And yes, just a little disclaimer. When I mention the name persistent, I mention it in the broader term. So historically, persistence equals database, nowadays is not true anymore. Again, you might have a service that persists after dropping a message in a queue or calling a REST endpoint. So take it in the broader sense of persistence. So saving data somewhere, even if this concern is externalized to another service. And the second main problem of having the domain depending on the persistence is that we need the infrastructure in order to test the domain. So if I want to test my business logic, I cannot just write a quick unit test. I need to spin up the real infrastructure, or more likely stub it, which means two things. The first one is that writing tests for testing the business logic is painful. It's not impossible, definitely, but it's kind of extra complicated by the fact that I need to implement something related to the persistent layer. And also they are slow. So they are not as fast as just testing a block of code in, I don't know, Java, Python, or whatever language you prefer. Because again, I need to at least stub or fake some of the infrastructure that the domain knows about. And the third and the last problem of having the domain depending on the persistence is that if the domain knows so much about persistent concern, we are going to likely have anemic domain. Anemic domain means that all our business rules do not reside inside the domain layer, but they are pushed in service. If you, for instance, if you have worked on a big Java enterprise project and you worked with Hibernate, which is an object relation mapper library, so something that basically maps the result of the query from the database to your object in the language that you use, in this case was Java, that classes, again, these domain classes are super bloated with code. There are annotation, there are reference to this library that needs to keep consistency, there are stuff like caches, and these classes are by themselves just so big because there is so much persistent concern that percolated inside the domain that instinctively you don't want to add behavior there. When I say behavior, I mean you don't want to have public methods that do a lot of stuff in this domain object. So you, at least in my case, that's what I did. I was more inclined to move the business rule in these services. So my domain was just data. So one class with little or non-public methods, they just contain data, and I just use them for mapping the information in the database to the domain. So I'll say in and out of the database. And all my logic was inside the domain. And this is bad for a bunch of reasons. Codes get difficult to understand because everything is in the same place in these services, and it's not so maintainable. So at this point, I hope that I clarified a little bit the problem that the onion architecture wants to solve. So again, trying to mitigate or actually solve the main pitfall of the legacy architecture pattern. But I'm going to stop first of all so that I can take a sip of water. And also, I'm very curious to understand if there are any questions about the problem before we jump on the onion architecture definition. All right. I'll take it as a no. I hope I'm not talking alone, but I'll continue in case just stop me.
No, you're not talking by yourself. So,
all right, cool.
Just a question, a quick question around, you mentioned object relational mappings. Do you have any feelings around them, or is it's just your opinion about this?
Controversial topic. I'm going to express my opinion, but I know that I'll take the arrogance of saying that the industry is kind of split like 50-50. I'm in the 50%, so in the half of the industry that do not like the object relational mapping. It's at least my experience with Hibernate. Again, nothing against Hibernate, probably my ignorance gave me much of the problem and not the tool itself. But the experience I had is very easy to bootstrap and set up this library. But then once you just derail a little bit out of the standard happy path, it gets super tricky. First of all, because you have things like caches, which are never easy to work with, even just to explain to other people who are not used to the tool. And in general, I felt it was extra complicated to work with. So if I could go back in some of the project where I was, I would say, I understand the domain is complicated and there are different, let's say, complex operation that we need to do to the database. But in that case, it was mostly because we had this monolith that probably should have been broken up in different places. So long story short, I'm not a big fan of object relational mappers like Hibernate, but again, personal opinion, and a lot of people actually love them because it simplifies development. It was not in my case.
You get a +1 vote from me on that. Always made my life more difficult than easier. But again, it's personal preference, right?
Yeah, I would say so. I hope not to get sued by Hibernate, but yeah, it's just the only library of this type that I work with. But yeah, you got my point. All right, then I'll continue. Ronnie, please stop me in case I have some lag and I don't hear you. And there are other questions or observations. All right, so all right, cool. So we arrived to the point where I hope it's clear what is the problem that the onion architecture wants to solve. Now let's go on the core part of the talk and let's define what the onion architecture is. So if someone asks you what is the onion architecture, you should probably come up with this smart answer, which is onion architecture is just layered architecture plus dependency inversion. This is a very smart answer. It's actually true, but I understand it's not very good if you are introduced to the concept of the onion architecture just now. So what I'm going to do is to explore both these two elements, layered architecture and dependency inversion, which are kind of the two pillars of the onion architecture pattern itself. And the layered architecture, actually, we already seen it. And if I display this picture to you, this is kind of the, if you stick to the way of saying one picture is worth 1,000 words, this is the kind of picture you will see if you Google onion architecture. So from this picture, you see that onion architecture is like layered architecture. It's actually a layered architecture pattern. And there are 3 layers. One is called infrastructure. The other one is called use cases or sometimes application, but I'm going to stick to the use cases term in this talk. And the last one, domain. So when I say that the onion architecture is a layered architecture, it means that if someone tells you, hey, can you please check this code that implements the onion architecture pattern? When you open it in IntelliJ or whatever IDE you want to use, you must see 3 top folders. One is called infrastructure, the other one is called use cases or application, and the other one is called domain. So there are, that's also why it's called the onion, because there are three different layers. And the second leg of the onion architecture is that this pattern prescribes that the dependency direction is always inwards. So this means that if you're an object inside the infrastructure folder, you can only know about other objects in the infrastructure folder or other objects inside the use cases folder or other objects inside the domain folder. While if you are an object that is defined inside the use case folder, you can either know objects inside the use cases folder or objects inside the domain folder. While in the end, if you are an object defined inside the domain folder, you can just know other objects defined in this domain folder. And that's basically it. So the layered architecture part is, again, these 3 layers. Don't you worry, we're going to see in a while what each layer contains. And the dependency inversion part instead is the trick we use in code so that this dependency is always inwards. So if you remember earlier when I said, when I was talking about the layered architecture and how the persistence was the persistence layer was the center of the universe, and how this happened kind of naturally, because the domain at some point needs to know about, I don't know, a database or something to create an output or to read an input. Well, dependency inversion is how in the onion architecture we make the domain free from the persistent layer. I totally understand that right now it's a little bit foggy, but in a couple of slides, we're gonna go through a full-fledged code example that I hope it clarifies a lot. But the main, let's say, key takeaway that I would like to instill in your mind is that the key point, the main value of the onion architecture pattern is that the domain is at the center of the universe. So there is not any more persistence and everything depends on the domain. And this is going to be super important when I'm going to explain let's say, the pros and cons, especially the pros of the onion architecture. So yeah, in a nutshell, this is what you need to imagine when you think about onion architecture: 3 layers, infrastructure, use cases, and domain. And this dependency direction always going inwards. There are no exceptions. Just this rule. I mean, if you follow this rule, you're going to implement the onion architecture pattern. So again, this is a high-level definition. what I'm going to do now is to explain a little bit more in detail what you should put in each of these 3 folders. And then we're going to also see a code example together, which I hope is going to clarify a lot of details that you might have in your mind. At least it was for me when I started studying this pattern. All right, so let's start from the outermost layer, the infrastructure. So in a nutshell, you should put in the infrastructure folder everything which relates to the outside world. So I don't know, database, REST endpoints, controller, HTML, CSS, the data transfer object, so the DTO that you use in order to contact an external service or to receive information about an external service. If you're reading a CSV file from the local file system, that still counts as outside world. So it should be inside the infrastructure folder. So you can think of the infrastructure folder as every mechanism that allows you, I mean, not you, but allows your application to receive input and to produce output. So for instance, if you're building also a web application, then everything that revolves around Spring Boot, which is a web application framework in Java. If you know, I don't know, Python, Django would be the equivalent. That stuff would be here inside the infrastructure folder. So if in the previous picture, you might have asked yourself, like, what is the persistence in these 3 layers? The implementation of the persistence is here. Here you're going to find Oracle, here you're going to find MySQL, here you're going to find SQL. The second folder instead, use cases, which again, sometimes is also referred as application. They are 100% synonyms. In this folder, you should see classes that are named as verbs, like add item to cart, checkout, remove item from cart. And these are basically the actions that you can perform on the application. And the main concern, like the reason for this class to exist, is to orchestrate domain objects. So these classes are super dumb in a good sense, meaning there is no business logic here. They just orchestrate domain object. Orchestrated means that they create a domain object, call a public method on it, take the result, pass it to another object, and again and again and again. So they are basically just plumbing. You should never put business logic here unless you're going to aim for anemic domain, which is something we definitely do not want. And the last folder is, of course, domain, so the center of our universe. And of course, here we're going to find all our concepts that revolve around the domain, plus the abstraction that we use to make the domain layer independent from the infrastructure. So this is the bit where the dependency inversion comes into place. I'm going to be a little bit high level now because I'm going to have a code example in the next slide. But basically, the trick that the onion architecture use in order to make the domain independent from the infrastructure is using dependency inversion. And dependency inversion use abstractions. So again, in the domain folder, you're going to have your domain objects, and that's expected, but also a bunch of abstractions, which is going to set you free. I mean, not you, but is going to set your domain free from any infrastructure concerns. And that's how you put the domain at the center of the universe, and that's how you make the domain not depending on anything. All right, I'll make another little pause before we jump on the code example, which is going to be a little bit dense. So I'm very happy to know if there are observations or questions about the different layers. And I'll take a little bit of water as well.
Yeah, Matteo, there is actually a question in the chat from Alessandro Minoccheri. I think it's the right pronunciation. So the question is, domain doesn't depend on anything, but what do you think about JPA annotations, for example? I prefer to avoid annotations like that, but sometimes I saw those in many models inside the domain.
Yes, so I hope this is going to be even more clear in the next slide, but at least you should have everything which is annotated with JPA annotation outside the domain, specifically in the infrastructure layer. So the way how you're going to persist your object, your information shouldn't be a concern of the domain. So even stuff like, I don't know, the annotation in Spring Boot, which is @transaction, which is for people not used, transactional, which is for people not used to the Java environment, an easy way with a library that so that you can implement transactionality inside your code base. Even that stuff should not be in the domain. So you should have these in the infrastructure layer. So your domain, as you're going to see, will just know about abstraction, and then the concrete implementation that will live in the infrastructure will know about this. So it's inside, again, the infrastructure layer that you're going to see class with, I don't know, at transactional, at JVA, or even at bean when you build up beans in Spring Boot. I'm very curious to understand if I answered the question. I know there is a little bit of delay between me talking and people writing, so I'll keep a little bit of seconds of awkward silence just to understand if, Mario, I got the question right or not.
Yeah, we are looking at the chat. Yeah, I completely agree with you. Yeah, that's the answer from Alessandro. I think another question also, if we have time, Matteo, you mentioned about the anemic domain. Are there any instances where using an anemic model is a good idea, in your opinion?
Okay, I'm gonna answer with a strong opinion, which is no. But actually, the thing is that it depends on what do you think, which kind of meaning do you associate with anemic domain. So, in general, no, I cannot think about a good reason for adding an anemic domain. The thing is that when I did the presentation, let me see if I can go back 1 second. When I showed this picture, I lied a little bit. I mean, lied or not. Let me explain a little bit better. I hope you can see my mouse, but basically in the domain layer, so in the core of the Onion architecture, there are domain objects, I don't know, shopper, cart, item, but also domain services. So the thing is, I'm not a big fan of domain services. So domain services are, I'll try to make this easy for the rest of, for all the audience, so I don't get into a rabbit hole. But basically, some people say, okay, I have sometimes some logic which I cannot put in one object. The typical example is, I don't know, if I have a collection of cards, what do? I have this list of cards in the use case where, I don't know, I can iterate over it, or I should have an object which is called cards with the S, or, I don't know, cart list, and then I put some logic there. This logic can be, I don't know, reduce this card, I don't know, take all these cards and apply, make the sum of the total, or apply the discount depending on the different content of the different cards. Some people will tell you, I will define something in the domain layer which is called service, I don't know, card service or something. I'm not a huge fan of this. It's not a dogma, but usually when I find myself creating a service, again, inside the domain, usually I stop and I say, okay, Matteo, probably you didn't get the domain right, and you are misplacing behavior. You are misplacing responsibility. So either I'm missing some concept that probably I didn't model properly, or I'm overcomplicating my life. So again, long story short, I think the anemic domain is always wrong in the sense of the object-oriented programming, of course. And usually is the smell that you have all your logic in one single place, usually services, and you can you are not leveraging all the power of the object-oriented kind of programming, so paradigm. That's the main pitfall of anemic domain. You can still get your software work properly, don't get me wrong, but you might be doing this in a more elegant, more simple way, just putting the logic inside the domain objects. I hope I didn't go too far with the answer, and yeah, it was clear enough. In case if I take it like from the wrong angle, I'm very happy to go back to this question at the end of the talk. Then Mario, I'll continue unless you tell me there is another question or for any other reason.
I think we can continue. There's another question relating the Onion architecture and the hexagonal architecture, but maybe we can come to that later. It's up to you.
Yes, Ronnie, because the spoiler, because at the end of the presentation, there's actually one slide dedicated to how the Onion architecture is different from clean architecture or hexagonal architecture, also known as porta and adapters. So I will keep these for myself, but with the promise that in 15 minutes, even less, we're gonna touch this.
That's good.
All right, then I'll moving on. Otherwise, again, you can just stop me. All right, so code example. The idea now is that I prepared a little toy project that implements the Onion architecture. So what I'm going to do is just walking through it and try to pinpoint the main important bits that the Onion architecture does to this code. So the main things that you should pay attention to. And I hope this code example clarifies most of the concepts that we have seen so far, which are mostly two: layered architecture, infrastructure use cases and domain, and the fact that the dependencies are always inwards. So the first step would be we open this project in IntelliJ, and again, we see 3 folders at the top level. One is called domain, one is called infrastructure, and one is called use cases. And you see already that, for instance, in the domain folder, that there is just one domain concept, which is cart, and you see this class called cart repository. So if you're used to Java and IntelliJ, looking at the green icon, you can already understand that this is going to be the abstraction that the dependency inversion will create. But again, we're going to touch this in a second. But again, domain, it contains domain object and the abstraction, which are a subproduct of the dependency inversion. Infrastructure is instead the real mechanism, so the real tech stack, the technology that we use in order to read inputs from the outside world and to produce output in the outside world. So there is something called cart controller, which smells like a web application. So it might be, I don't know, that we are exposing a REST endpoint. And there is something called cart API, which might be a database, might just be another REST service that we call to persist our information. I don't know. We're going to check this out in a couple of minutes. And the only verb, the only action that we can perform on our application is getting a cart, so retrieving a cart. All right, so let's start from the outer layer and see the internals of this code. So let's start from the infrastructure. In the infrastructure folder, we find this cart controller, which is a pretty simple class. This class takes one collaborator, which is this getCart object. And the only logic of this class is this getCart method, the one at the very bottom. This method takes as an input a string and then returns you a cart. And it does it using the getCart, so the use case. And the thing I would like to highlight to you is that the dependency are pointing inwards, meaning this cart controller needs to work something called getCart and something called cart. And they respectively come from use cases and domain. And because they are inside this onion, the dependency direction is pointing inwards, which means the onion architecture pattern is happy. So we are doing a good job. Let's now move inside one layer and see what do we have inside use cases. So inside this folder, we have just one class, which is called getCart. And this class will take as a collaborator this object called cart repository. And the only logic of this class is this public method called apply, again, the very bottom of this snippet of code. And you see here the orchestration. So apply, what does apply do? It uses the repository for fetching a cart and then call a public method called redeem discounts, which returns a discounted cart, and then return the discounted cart to whoever called this apply method. So you see here, there is no business logic. I'm just gluing stuff together. It's just plumbing. And again, take a look at the import statement. So we are in the use case folder, and we just reference stuff which is inside the domain folder, which are the cart object and the cart repository. And so far, so cool. It should have been quite linear so far. But at this point, I mean, let's jump on the domain, and this is where things get tricky. If you are the first time, if you have been exposed to the Onion architecture for the first time in this talk. In the domain folder, we found this object called cart, and this is pretty cool. I mean, I didn't have much fantasy, so this redeem discounts just return you a cart, but we are cool. This class does not depend on anything. So again, the Onion architecture pattern is happy, but this is the core, and I think also the most difficult thing to assimilate, to understand about the Onion architecture. So at this point, we need to fetch this cart from somewhere. This might be a database, this might be a REST service, we don't know. And the thing we're going to find inside the domain is this class called cart repository. If you're used to Java, actually, this is not a class. This is an interface, which in a general sense is an abstraction. This is an abstraction because we are just defining the signature of get card, but there is no body. So we actually don't know how we're going to fetch this card. Again, it might be from a file, might be from a queue, might be from a database, we don't know. But inside the domain package, so again, the domain folder, we are defining this abstraction. And this is the dependency inversion in action. So at this point, we would be forced to know something about infrastructure. Again, I would need to write a query in SQL, like select something from card table. And instead, I'm going to define this abstraction here in the domain, because then in the real class that implements the fetching of this card, I'm going to implement the real body of this get card. I'm going to slow down a little bit here because I think it's the most complicated part of this talk. So again, on the left, we define the abstraction and we are in the domain folder. Instead, moving on the right, we are back in the infrastructure folder where the card API lives. And this card API implements the card repository. Implements is a keyword in Java that means I'm going to obey to the signature that you define in this card repository, and I'm going to provide you a body to this. I'm returning null because I didn't know what to write, but here you can think of, I don't know, again, doing a select on a database or fetching some information from a third-party API, reading from a queue, you name it, again, using the ID. And this is the important bit. So we are in the infrastructure layer and we are pointing inwards. So we are pointing into the domain because we need to know the card repository. And this is the inversion taking place. So this is the thing that was missing in the layered architecture, but actually the onion architecture is able to do with the dependency inversion. So this comes with the cost of defining an abstraction in the domain, which is the class on the left, card repository. But the good thing is that the domain doesn't know anything about the infrastructure. On the other hand, the infrastructure needs to know about the domain. So the card API is providing the concrete implementation for retrieving the card. But in terms of onion architecture, so in terms of inwards dependency, everything is great. So the pattern is respected, which means that, for instance, if instead of having return null here on the right, imagine here I would do return select from table, etc., etc. If tomorrow I would change that select with, I don't know, reading from a queue, I would just need to touch this card API class. Everything on the left, so the card repository, but also if I'm going back to the get card here, nothing would change. So everything is encapsulated in the right side of this slide, so in infrastructure. Again, thanks to the abstraction here on the left, card repository, which is the dependency inversion in action. I talk a lot. I hope I didn't over talk, but I really want to stress this inversion because it's the core part of the onion architecture as a pattern. So at this point, we should have a good understanding of how the different things are panned out. And the only thing I would like to show you though is the main. So these are all the classes together, but I want to show you like a use case of how we exercise our application and how we actually retrieve a card using our application. And this is the main. Again, in the reapplication, this might not make much sense, but actually it's a pretty good example for this code base because it's pretty simple. So let's read this line by line. So in this main method, we first define the get card and the card controller. And the interesting bit here is that get card, which again lives inside the use case, has been passed the card API. So the main is the only point in our code base where we kind of reconcile the dependency inversion. So it's the only place where we know that the concrete implementation of the card repository will be a card API, which again might be a REST endpoint, but here I could pass, I don't know, card queue or card REST endpoint or card SQL repository. And in a real project, I mean, in an enterprise project, this stuff is not done by hand. You usually use a dependency injection tool. I don't know, Spring if you're coming from Java or Dagger or whatever tool is used, whatever library you use for dependency injection. But you can do 100% of this manually. It just takes a little bit more time, but you just create new and you can pass all the objects that you want. All right, I'll stop here before we go on the second part of the talk. And I'm really curious to see if there are questions, because this code example, I think, is the most dense part of the talk.
So there was a question from Fabio, who asked, what happens if the method redeem discounts needs to reach a web service to accomplish the task, for instance? Will we then introduce a dependency from a service into the domain? And in the chat, Matteo Vaccari answered, you would then use dependency inversion again.
Yes, correct. Correct. Matteo Vaccari is totally right. So let me see. Sorry, I lost it. So if let's assume for some reason, which might be a very reasonable reason, I want to write something into a database here inside this cart. Inside the constructor of cart, or inside the redeem discount as an input parameter, we would receive a cart repository. And I don't know, this cart repository might have a save cart, or I don't know, update cart, or whatever. So you would pass here just the abstraction. So at this point here, you would have you would need to know about the cart repository. But the cart repository lives in the same package as you do. I mean, not you, Fabio, but you cart. So in that case, the dependency direction is still inwards. The cart doesn't know about how you are retrieving this cart, and everybody is happy, if you like, on your architecture, of course.
I think that answers the questions. Yeah.
Okay. I feel like my mother, who is a teacher and always has no voice now, I finally understand her. But I mean, I tend to talk a lot. All right, so we made it. We cleared the first leg of the talk. So at this point, we should be already able to answer the question, what is the onion architecture? And in case you didn't get it, my fault, I probably was not clear enough. So the rest of the talk is actually quite short and sweet. So we have passed the most dense part of the talk. And on this second leg, I'm going to focus on why should I use the onion architecture. So as anything is in life, especially with patterns, there are good things and bad things, because it's just a compromise. And I'll start with the good things first, though. So you might have guessed the main pro of using the onion architecture is domain stability. So if the domain is the center of the universe, whatever changes around, it doesn't matter. You could make a complete migration from, I don't know, relational database to non-relational database. You will never change anything inside the domain and use cases. So the only reason why domain will change is because your business rule will change. So your product owner comes and say, hey, regulation has changed, we need to do this modification. And this is so much important and so much cool, especially if your domain is complex, because basically, again, the only reason why your domain will change is because really there is something that's changed. So all the noise around never touches the domain and the use cases folder, the use cases classes as well. The second benefit is testing. And the reason being that if all your infrastructure is out of your domain and use cases folder, you can write very easy to write and very quick functional tests, meaning you can test the whole business logic of your application without needing to know about Docker, without faking database, without using WireMock, without needing to install test containers. And this usually, at least in my experience, meant two things. Because tests were easy to write, because again, for instance, in the context of Java, you just need JUnit, maybe Mockito if you want to stub something, but again, just for stubbing. So it's very easy to write tests. And at the same time, they are also very fast to be executed, because you can think of them like at the same speed you run the unit test. And this means that these tests, automated tests, run very quickly inside your local environment, and also the continuous integration or also continuous deployment pipeline runs very quickly. So all developers are kind of nudged to write these tests because they are a wonder to write and are also a wonder to execute because they are super fast. And here, what usually, here I'm calling them functional tests because it's not really acceptance test. So again, I'm not advocating for getting rid of acceptance tests. You will still have your pyramid with acceptance tests on top, which are tests that spin up the whole application, infrastructure included. But then if you just want to test your domain, you can write this stuff that at least in my previous teams were called functional tests. And I've seen these go very well in hand with parameterized tests. So I was in a couple of projects where we would have parameterized tests, so a bunch of different input that were simulating the different input being received from the users, but also from external sources, and then trying all different kind of scenarios. So this is very, very good, not just in terms of test coverage, so how much code you exercise, but also but specifically and most importantly in terms of test quality, because you can really hammer your application looking for bugs, and you can very quickly explore edge cases that would take ages to run in acceptance test, and in the end you will never do because they are just too slow. Again, little disclaimer, I'm not saying that you do not write an integration test for infrastructure, you still do it, but there is also the benefit there that everything is in one place, so it's also easier to reuse code. But again, the most important part is that you can test all your business logic without needing to worry about infrastructure. Another cool thing, which I think is underrated, is readability. So at least when I start a new project, these are the three main questions I ask to myself. So what can I do with this app? What is the domain? And what is the tech stack? Like, do I need to study something new? There are some gaps that I need to cover quickly. And the cool thing is that there is a one-to-one mapping between these questions and the folder of the owner architecture, at least a project that implements the owner architecture pattern. So if you want to know what you can do with the hub without the H, you can go to the application folder. And here you're going to find the verbs. So it seems that in this application, I can add an item to cart, I can check out, and I can remove item from a cart. So for instance, an action like add to wish list is not here. If instead you want to understand in which domain are we, I don't know, it's a bank, it's an e-commerce, it's an insurance, you can just explode or say open the domain folder. So here we read cart, there is an inventory, there is an item, there is shopper. So very, very likely we are in the domain of e-commerce. And instead, if you are interested about the concrete technological stuff, like which tools do we use, you can open the infrastructure folder. So here we see we use very likely a relational database, and we're using REST. So for instance, if I don't know how to work on queues, I should be fine on this project. Again, I'm not saying that if you just read these three folders, you know 100% of the project, but it's a very, very good start. And it really helps you navigate in the project and also reason about it. And the last thing is the independent delivery mechanism. Again, because all the infrastructure is pushed on the outermost layer of the application you're writing, you can quickly swap technology. So let's assume, for instance, that we are working on a web application and we're using this framework called Spring Boot. And I don't know, the CTO comes and say, hey, from the next week, everybody needs to migrate to Micronaut, which is another web application framework. And the thing you can do is just go to IntelliJ, select the domain folder, select the use case folder, right click, copy, and then paste it in another project. And the only thing left at that point is building from scratch only the infrastructure folder using this other framework called Micronaut. But all the code that you copied from the use cases and domain will be 100% reusable. You don't need to touch it at all. And you can push this further and say, if you strictly implement the onion architecture pattern and you develop a web application, you might move it to a mobile application, just redoing from scratch the outer layer. So again, you save 100% of the code you have written without any need for change anything in the use case and domain folder, and you can just redo the external layer. On this last bit, I hope this slide sparked a little bit of controversy. So the last time I worked on mobile application, I think it was 7 years ago, something like that. It was like Android KitKat. So in theory, this is possible to switch from mobile to web application to mobile application, that is, so saving 100% of the domain and use case folder. But I'm very happy to know if there are some mobile developer inside the audience that say, yes, in theory is possible, but this stuff will clash so much with the kind of architecture which are pushed by Android and Apple. because honestly, I don't know how Apple, for instance, encourages to split the different concerns. I don't know, UI, persistence, domain, authentication, and so on and so forth. So again, I think it's possible to do this transition from web to mobile, just removing the outer layer, but I don't know if this clashes a lot with recommended, let's say, architectural pattern in the mobile world. Again, because I've been a long time since I've written a mobile app. And if you have this kind of experience, please, Ronnie, let me know if someone wrote about this. Otherwise, I'll skip to the next slide.
There are no comments that I can see of. Mario, do we have questions about this?
So we have a question from Giorgio Boa. So the question was, in JPA, a valid repository can be a simple interface that extends JPA repository. So where should I put my cart repository, that simple extend JPA repository? I think there is also a conversation. If you want, I can tell you about it. So Matteo Cari was replying. The JPA annotation is a dependency on the persistent library. So you can wrap it with an adapter, use the dependency inversion on your, or you can break the onion rules and pass the JPA repository to the model, or you can avoid JPA.
Yes, I think my answer would be very much in line with the one of Matteo Vaccari. So if I had to do it, I would. You don't want to have that JPA mentioning inside your domain, because maybe you change your persistent technology in 1 month, and you will need to be forced to change stuff inside the domain. So you still have the cart repository interface, the one that you've written in Java, like plain Java, inside the domain, and then you have the JPA one defined in the infrastructure. If I explain myself clearly. And again, I'm also doing a +1 on the adapter part. So the adapter pattern is basically, and this is, I think, is useful to do whenever you use external library, even for logging. So instead of having to use directly the library that implements logging, a good thing that I've seen in the previous project is that you should wrap in your own class. So I don't know, you are using log4j, but instead of directly using that directly in the, I say directly too much. Instead of using that log4j library directly inside your classes in all the part of your code base, you should define one class, which is called, I don't know, mylogger or Matteo logger, pass it inside the log4j, and that this mylogger class will expose the classical methods that you would use to log, I don't know, error that receives a strings, info that receives the strings, and so on and so forth. The benefit of this is that if you tomorrow you want to change the kind of library they use for logging, you just need to change it in one place in your code. I don't know, maybe you want to switch to a library which does asynchronous logging, and your current library doesn't allow you to do this. So without an adapter pattern, you would be forced to do a string search and replace, or even worse, in all the code base. While if you use an adapter, you have literally one class in your code where you can just remove the old library and put the new one. And the rest of your code will be oblivious of the fact that you removed this library. Again, I'm going away from the onion architecture, and I'm touching another different concept, which is the adapter pattern. But I think what Matteo Vaccari suggested is a good thing, or is a good way of doing things in this case. And this also applies to the JPA repository, I would say. Sorry if I took it a little bit away from the question.
No, that's great. We don't have any more comments in the chat right now, so if anything will come, we will pass to you towards the end of the talk.
All right, cool. I know we have just 2 minutes, but I think in 5 minutes we can close it. I will try not to rush, also because this is recorded, but we are very close to the end. All right, like everything in life, there are also cons. And the main cons, in my opinion, is that dependency inversion is hard to understand. So onion architecture does a heavy use of dependency inversion. And if you're not used to it, it might be a little bit tricky to understand. Especially when you navigate code, you hit the abstraction, then you don't understand where this is resolved, so where the concrete implementation is. So especially if you don't have much experience, might be a little bit overwhelming. But I still think that once you understand it, the pros overcome the cons. And the second thing is that, again, personal suggestion. I think the onion architecture is not worth to implement it if your domain and application layers are very thin. This is typical the scenario with CRUD applications. So create, read, update, and delete apps. I don't know, a web app which receive a string and then which is an ID, and then fetch an item, something from a database using that ID. In that case, the onion architecture is not worth, I would say, because you still have all these layers, and especially you have the dependency in inversion, so all these abstractions, but then your domain is basically pointless. Like your domain object do not have any public methods which contains any meanings. They are just data structure, meaning containers that you can put the data that you read from the database to return to the caller, or the other way around. When you convert the post body, for instance, of a HTTP request, then you write this information inside this object and you persist it with the database. And the use case classes as well will be super stupid. Usually they will be one line. I get called with some input, I use the repository for fetching something or for writing something, that's the end of it. So it's probably not worth to go to the extent of defining so many abstraction if the application is so simple. Cool. I'll take to the last leg of the talk, which is how to implement the onion architecture. And surprisingly, it's super easy. I'm not oversimplifying, and you literally need to know just 3 things. You need to perform 3 steps. The first one is that you start a new project and you create 3 folders. And I guess you, at this point, you already know the names. So right click, new folder, infrastructure, another one called use cases, and another one called domain. You do it once, you have done, you're cool forever with the project, unless you delete it, of course, but yeah, that's another story. Second step, when you create a new folder, you need to ask yourself, okay, where should I put this? Is this something related to the outside world? Okay, I'll put it in the infrastructure folder. Is this a new action, like a new feature that the application exposes? Then it goes inside the use cases. So it's going to be an orchestrator. And instead, if it's a domain concept, you put it inside the domain folder, of course. And the last and most important step is that whenever you find yourself violating the dependency in direction that needs to go inwards, you use dependency inversion to create an abstraction. Typical thing, as the question from Fabio, I inside the card, I have this information of the card that I want to write something. I want to persist this in a database. I'm tempted to do an SQL query, for instance, refrain from doing that, create an abstraction, so an interface in case of Java, for instance, and then you put the real SQL code in the infrastructure. If you follow these 3 steps, then you can keep this inwards dependency that the onion architecture prescribes, and that's the end of it. All right. Right in time, actually 2 minutes more. With this part, I should be able to have kept the promise. So at this point, everybody should be able to answer the 3 questions. What is the onion architecture? Why should I use it? And how to implement it? Now, if you want to stay with me, there are a couple of, let's say, fun facts, or let's say ancillaries, and they are literally 3 slides. Otherwise, I think the promise is kept. But if you want to stay, I can go on a little bit. Again, I think they're going to take 3 minutes. But I'm very happy to see if there are questions at this point.
Okay, so there was another question, I think, related to the previous one that we were discussing, but you know, a little bit of lag. So the question is from Alberto, and is where would you place that logging adapter? Would it be a domain concept if I need to log something in a domain entity?
Nice question. This is actually a question I asked to the Alberto. I don't know if it's the same Alberto. So when I was in Spain and I was working with this guy, he was the one introducing me to the onion architecture. So I think about it, a little bit of code, and then one day I came back and said, okay, what about logging? Like if I need to log inside the domain, what do I do? Logging is something that usually is pervasive in my code base. So where should I log if I need to log, for instance, in the cart? And the discussion then came up, and I mean, most of these answer is coming from him, and I 100% subscribe them, are the following. So the first observation that he made to me was, usually when you log, you never log inside the domain. So when you log, usually you're interested about the integration with your system with the outside world. So usually you log when you receive inputs, for instance, when you receive an HTTP request, or when you contact external party. I don't know, I contacted the REST service for fetching some data, so want to know if everything was cool, or if there was an error where this error happened. And again, for instance, validation is also something that you usually do on the outside, on the boundaries of your application. So again, in the infrastructure layer. First observation. The second observation was like, dude, it's just a pattern. If it overcomplicates your life, just log it. You need a log inside a domain, just put the log. It's fine. We shouldn't be too much dramatic, and I definitely agree with this. But he also suggested me, if you really want to be not extra smart, but like extra pure with this on your architecture pattern, the thing that you could do is just dispatch an event, like for instance, an event which is a domain event. And then you just, let me start from scratch. I'm inside the domain, I need to log something, but I really don't want to introduce this dependency with the logging library, which is of course infrastructure. So what you do is that instead of logging, you just throw an event. Not exception. I'm talking about dispatching an event. And then in the infrastructure layer, you have something who is listening on events, catches this event and then log it. So in this case, you can still keep your domain as pure because these events are domain events, but the act of fetching this event and then writing them on a file or writing them on the network so you can see them in Kibana would be done in the infrastructure layer. Again, you need to understand if it's worth doing this extra effort. So I would say either log it, it's fine, nobody dies at the end of the day, especially because logging is not such a big deal. But again, as Matteo Vaccari said, use an adapter pattern so that if you need to change something, it's just one point. Otherwise, you can try with this logging pattern with dispatching an event and then letting someone in infrastructure listening to events and then writing a log.
Great. I think no more questions from the chat. Actually, some congratulations and thanks are already coming. So probably over to you to wrap up your talk.
All right, just 3 slides and then I'll shut up, I promise. So auxiliaries, let's say fun facts about Onion architecture. The first thing is that Onion architecture goes very well hand in hand with DDD, domain-driven design. And the thing is that these both, you can think them as school of thinking, the one of Onion architecture and the one of DDD. And they both put a lot of emphasis about the domain. The domain is the center of the universe, it's the most important thing. And the Onion architecture takes everything which is not domain, meaning infrastructure, and push it outwards. So your domain is pure, like there are just domain concerns. And that's why usually Onion architecture as a pattern is very well considered by people who like also DDD. And this also happened with functional programming, because again, because all the infrastructure is on the edge of your application, this is where the side effects happen. Side effects, it means your application needs to produce an output usually. And again, if everything that produces an output is on the very edge of your application, the core of your app, again, the use case and especially the domain can be pure in terms of functional programming. Here, I'm using the word pure in the sense that it's free from side effects. And all these side effects are on the very edge of your app. And this is where you can tackle them. And the last thing, and I'm hoping also to reply to the question which was asked previously, is that what's the difference with Onion architecture, clean architecture, and hexagonal architecture? I'm going to go to the extent of oversimplifying a little bit and say they are mostly the same thing. So Onion architecture, clean architecture, and hexagonal architecture, which is also called, used to be called port and adapters, is that they say 2 things. You should have layers and you should point inwards with this layer, and the domain should be the most important thing. Now, hexagonal architecture introduces much more nuances. So for instance, when you talk about abstraction that you define, when you talk about the implementation of the abstraction that you define the domain, which in the hexagonal architecture are called adapters, the hexagonal architecture say there are different kind of adapters. So the one for the input, the one for the output. Instead of one of the input, you could have one for actually your business, and instead other one for administration. My personal take is that I really like onion architecture because it's super simple. In some cases, you want to be very, very disciplined, also a little bit more formal, and you really have a lot of, let's say, a complex context, then maybe aim for hexagonal architecture. I actually, I mean, not that I have this huge experience, but in the little experience I had, I never felt this need to go to the extra mile and say, okay, I think we really could benefit from hexagonal architecture. And again, the core of it is the same thing, but I really prefer onion because in my case it was very easy to understand. And it was also, I think, is much more easier to explain to people who you need to onboard on a project. At the end of this talk, I also put some sources, and there is a nice article from Mark Seaman, if I remember correctly. And this person does a nice comparison between onion architecture and hexagonal architecture. So I really encourage to read his blog post because it's much better than my explanation. But again, long story short, more or less are the same thing. Hexagonal architecture has more nuances. Clean architecture is just the description of the different features that an architecture should have in order to be very maintainable and in order to have the domain not to depend on concerns like infrastructure. And onion architecture is actually a concrete implementation of these prescriptive principles that are mentioned in the clean architecture description. Last thing, some people ask me, okay, so because the database and the UI are in the same folder, I can call the database from the UI, no? And the answer is, of course not. So the onion architecture does not explicitly and formally forbids you to do this, which instead the hexagonal architecture does, but don't do it. It's of course bad, and you should be very aware of how different parts of the same layer talk with each other. This is especially true for the infrastructure layer. So don't do it, and don't say that I encourage this. But jokes aside, this is a typical question that might arise, and the answer is of course no. These are the sources. Jeffrey Palermo is the person who he did not invent the idea behind the onion architecture, but it was the person who gave it a name. So that's why I reference it here. The second link is the one about onion architecture versus hexagonal architecture, and finally the clean architecture blog post from Robert Martin, if you want to dive deeper in these three different concepts. And I think that's it. So I'm happy to receive any question. Otherwise, I'll shut up and just say thank you to everybody who attended.
Thanks, Matteo. That was really, really good. Anyone else? Are there any other questions that we should ask Matteo? Shall we try and wrap up? So I'll share the next events. So if we were in the same room, I would say big round of applause for Matteo and his talk. I encourage you all to write any feedback you might want to add to the chat or to us in the meetup. And I'll just very quickly give you an overview of the next events. So Matteo again is going to do this talk again for us, for the Share It community, but in Italian. So if you speak Italian, you would like to hear it again, or if any of your friends you think might be interested to hear the talk in Italian, Matteo is actually doing it again tomorrow, same time. So please spread the word. And then next month, we're going to hear Matthew Johnson, a colleague from the London office, talk about inclusivity and a day in a thought worker's life. I would recommend it to everyone. If you haven't already, Matthew is a testimonial for subtitles in Google's phones. You will find it in their own media. So again, please make sure to give us as much feedback as we can. We try and improve this community every time, and we aim to provide it as a service where we can for people who might be interested. So, virtual applause for Matteo, and thank you all for joining our second event. Hopefully see you tomorrow and next month and the next coming. Thank you all.